Alright, so here we are on lesson 5, using the identity and inverse to write equivalent expressions. So you should be on page 12 of your note packet. Alright, in the opening exercise it says, in the morning Harrison checked the temperature outside to find that it was negative 12 degrees Fahrenheit. Later in the afternoon, the temperature rose 12 degrees Fahrenheit. Write an expression representing the temperature change. What was the afternoon temperature? Alright, so in the morning, we were at negative 12, but then later in the afternoon the temperature had rose, so that means we're adding 12. Alright, so we have negative 12 plus 12, and that would just be 0, right? So the afternoon temperature was only 0 degrees Fahrenheit, which is super cold. Alright, so down here, in where it says number 12, it says rewrite subtraction as adding the inverse, for the following problems and find the sum. Okay, so we are using that inverse now. So we're going to rewrite this as 2 plus a negative 2. Alright, and 2 plus a negative 2 gives us just 0, right? So for part B, we'll rewrite it as negative 4. We have a double negative here, so we just add 4, adding 4. We know negative 4 plus 4 gives us 0. This one says the difference of 5 and 5, so it would be 5, then the difference minus 5, which would just be 0. Alright, and then here, if we have g minus g, always think of it, if there's no letter or number in front, it's 1g minus 1g, which would just be 0, right? So, number 13 asks you, what pattern can you deduce from the opening exercises? I want you to do on your own, and we'll share in class. Alright, I think some of you probably already see it though. Alright, number 14 here says to add or subtract, so this is pretty much just like normal. So we have 16 plus 0 gives us 16. 0 minus 7 would just be negative 7, right? Negative 4 plus 0 would just be negative 4. And then 0 plus d, we're not adding anything, so it would just be d, right? So then part B here says, what patterns do you notice from up above? I want you to do this on your own. I don't want to give that to you. And we will go over it in class. Okay. We are going to skip number 15 right now, so cross it off. We're not going to do that. So I want you to flip over to the next page. Alright. Example 1 says to write the sum and then write an equivalent expression by collecting like terms and removing parentheses. Okay. So on part A, I want you to cross off and 5x. We're not going to use it. So it says 2x and negative 2x plus 3. So remember, that means to add. So we have 2x plus, in parentheses, negative 2x plus 3. So now if we rewrite it without the parentheses, right, we would just have 2x minus 2x plus 3. That addition symbol doesn't change anything. 2x minus 2x is 0x, so it's gone. These cancel, so we are just left with 3. Alright, part B says 2x minus 7 and the opposite of 2x. So this would be 2x minus 7 and means to add. The opposite of 2x would be a negative 2x, right? So now if we rewrite it without parentheses, we'd have 2x minus 7, and then this would just be minus 2x. And again, 2x minus 2x, those cancel, so we're just left with negative 7. Alright? Part B says the opposite of 5x minus 1. So the opposite of positive quantity 5x minus 1 would just be a negative. But now I want to distribute that negative to both parts, so this would be negative 5x plus 1. That's as much as we can do there. Okay. Exercise 1 here, we're going to do this in class, so you can just skip it for now because we don't have partners and I do want to try this in class altogether. Alright, so we're going to skip now to the last page, page 14. Alright, So if you look at example 2 here, these are just some examples here. We have 3/4 times 4/3, 4 times a fourth. Alright, so if we look at these, 3/4 times 4/3, right? If we cross divide here, we get 1, we get 1 here, so we just get 1. Alright, 4 times a fourth, if we cross divide, would also just give us 1. 1/9 times 9/1, if we cross divide, would give us 1. Okay, negative 1/3 times -3 would also give us just 1. And then negative 6/5 times -5/6 would also just give us 1 if we cross divide. Okay, so here you can see we are using the multiplicative inverse. Alright, we kind of talked about that when we talked about properties in the last unit. So, in our last example here, it says write the product and then write the expression in standard form by removing parentheses and combining like terms. So it says the multiplicative inverse of 1/5 and 2x minus 5. So it says write it as a product. So the multiplicative inverse of 1/5 would just be 5/1, right? Or 5. And now we are multiplying, so we would have 2x minus 1/5 on the inside. And now if we just multiply with 5 times 2x would give us 10x. And then 5 times negative 1/5 would just give us a minus 1. Alright, part H says the multiplicative inverse of 2 and the quantity 2x plus 4. So the multiplicative inverse of 2 is just 1/2. And then we're going to multiply times 2x plus 4. So if we distribute that 1/2, 1/2 times 2x would just be x, and then 1/2 times 4 would just give us a plus 2. Alright, if you need to see that off to the side, right, 1/2 times 4/1, we cross divide, we get a 1 and a 2, so we would just get 2. Alright, so now the last one, a little tricky. It says the multiplicative inverse of the quantity 1/3x plus 5 and 1/3. So the multiplicative inverse of this, think of this just as a fraction. So now we're going to flip it. So we would have just 3x plus 5 in parentheses, and then we're multiplying by 1/3. So that means when we distribute, 1/3 times 3 would just be x. And then 5 times 1/3 would be a positive 5/3. Alright. So exercise 2 here. I want you to try this on your own. Remember that reciprocal and multiplicative inverse mean the same thing. If you need to write yourself a note, put reciprocal equals inverse. Alright, I want you to try these on your own, and then we will go over them in class all together.